the two surfaces here and here, the elliptical hyperboloid and the sphere, will intersect when the x, y, and z coordinates of each are equal. To determine where that intersection occurs, we can simply eliminate z between these equations, or we can begin by eliminating z, and we add the two equations. We get 5x squared plus 10y squared equals 52. Okay, well, that's an ellipse. That's approximately x squared over 52 fifths, about 10, so that's about x squared over 3.3 squared, plus y squared over about 5, so that's going to be about 2.2 squared, equals 1. In the XYZ coordinate system, see if I have room over here. That is simply an ellipse that we could easily construct within a rectangle of the XY plane, because eliminating z, we can actually sketch this surface for any value of z. It's going to be the same. In any plane, we're going to have 5x squared plus 10y squared equals 52. Doesn't matter what z is. What this means is we can construct our rectangle down here, and you can worry about the details of that. And here's our ellipse. If we move up to a higher plane with a different value of z, it doesn't make any difference. We get exactly the same dimensions, exactly the same ellipse, only higher or lower, meaning that what we effectively get is an elliptical cylinder. Now this looks like it narrows just because I didn't draw it very accurately, but this is an elliptical cylinder, and it also comes down below the axis. So that these two surfaces intersect on points that lie only on this cylinder. And I guess I should probably come down here and attempt to draw it below the axis just for some sort of completeness. See if I can get the scale about right. So we can bring this on down to here. Now we could make this picture a little better by dotting the lines behind here, but you get the idea of this elliptic cylinder. Now, I'm not going to attempt to superimpose the graph of our quadric surface, but you recall that the quadric surface for the sphere, well, maybe we can just about superimpose the quadric surface for the sphere. The quadric surface for the sphere is going to have radius 4, meaning that the sphere is going to lie somewhere a little bit outside of this ellipse, at least down here in the XY plane. I'm going to dot the graph of the circle where it intersects the XY plane. It's going to intersect the XZ plane up here and down below. So it's like two perpendicular rings. And it's going to do the same. That's the YZ plane. It's going to do the same in the XZ plane. So it's going to come up like this, down like this. Now that's getting to be a mess, but if I kind of draw little rings around it, we can begin to see the sphere emerge. And it's clear that that sphere does intersect this elliptical cylinder. It might be a little bit difficult to draw the locus of points, and this picture's already messy enough, so I'm not even going to attempt that, but the intersection, there's an intersection about here, there are intersection points that form a curve, and we can get some idea of what this intersection looks like. Now, had we drawn the hyperboloid, the elliptical hyperboloid that represents this surface, it would have intersected this vertical cylinder, this elliptical cylinder, in exactly the same points that the sphere does. So that this intersection lies on a curve above this ellipse, so here's the ellipse, and there are points above this ellipse where we intersect. At each point above the ellipse, there's some point where we intersect this curve. So the curve might look something, we don't know what it looks like. I'm just drawing a general curve. We don't really know how it goes, but it lies above the ellipse in the XZ plane. So we can imagine some sort of a curve up here. Doesn't look anything like this. And that would be the same curve where the hyperbolic, the elliptical hyperboloid intersects this cylinder. Okay, and that would be the intersection of these two surfaces. Much more regular than I've drawn it. You can think about what it might look like. But by eliminating z between the two equations, we find a locus of points in the xy plane, and the intersection lies above, and there will also be a symmetric intersection below the xy plane.